everyone, my name is Julie, my partner is Seth. Today I would like to talk about how I stimulate the GG1 query in MATLAB, and in the next few minutes my partner Seth is gonna talking about how we stimulate the Hoppy Stone by using MATLAB. So first of all, I want to discuss a little bit about the concept of GG1 query. So there are three main factors in this system. The first one is the entities, which means we have an arrival generator, a server, as well as an individual customer. The next one is there's gonna be a condition. So if the server time is gonna equal the next departure is scheduled, and if the server is busy, we're gonna have the server times equal at a server duration. And if the server is available, which means the server time is gonna be infinity. And this one I want to show you a visualization how the idea system gonna be, and the bottom one is gonna be the majority gonna be happen in our system. So at the top, the first customer in and out, and the service time gonna be in the range when the customer 2 is gonna be later than that. And in the picture at the bottom, when the service time for the customer 1 is take too long, so the second customer have to be wait, and that's gonna be take our system to delay. So now I'm going to how we stimulate GG1 by using the MATLAB. So when I'm run this one, you can see that we have the mean cycle length gonna equal 6, with the lambda is 1, the mu is 2, the gamma 1, and the beta is 1. As you can see, the feature ones here is obvious that like the majority customers is gonna be wait and take so long over the time, and we run this time for 10,000 times, and we will see this. So thanks for watching.
Here in the Dagpunar textbook, we have an example of a hospital ward. In this case, much like the GG1, we want our inter-arrival time at its mean to be greater than the service time, so that we have some telling statistics that we can find. As we talked about before in the three-phase terminology, in this case we'll be looking at two specific bound events, which are the arrival of a customer into the system and a normal scheduled departure time. We also have some conditional events that we'll be looking at, which are the normal admission of a patient and the admission of a patient following an early departure, which basically is someone fitting into the schedule when a departure is done earlier than scheduled, and the referral of the arriving patient. And we can see much of this in the code. For example, we have different conditions that will apply if the clock is at a certain value, where we'll have that arrival of a customer, departure of a customer, or we'll also have some conditional states if some of those conditions are true for the admission of a patient following an early departure, or the referral of an arriving patient. So running this code, we can find that since more people are departing than entering the system, we have an average utilization of the beds within the system of 1, and the average referral rate that's going on for customers to be referred is about 95%, which is also high. And we can also look at the bed occupancy distribution, where we have a majority of it very low but spiking up at the very end as it reaches 10 for the occupancy of that. Thank you for watching.